My name is Paul Berkman. I have the pleasure and honor to chair the session, also to serve on the steering committee for this conference. The conference has the concept of science diplomacy, and as Vaughn mentioned this morning, there is the realistic opportunity to develop science diplomacy as an international global field. This session will focus on transboundary and shared resources. I'll provide some opening remarks in a moment, but I'd like to first introduce the four distinguished members of the panel. Dr. Tim Dye, who is works in medical informatics, will talk about data diplomacy. Dr. Christina Yerde, who is an expert on areas beyond national jurisdiction. We'll talk about the marine environment, in particular the high seas and the deep sea. And Ambassador David Bolton from the State Department, who has the distinguished opportunity, responsibility of serving as a senior Arctic official for the U.S. chairmanship of the Arctic Council. And David will talk about the high seas in the center of the Arctic Ocean and fisheries there. So in terms of the concepts of science diplomacy and thinking about this conference and the opportunities going forward, in a sense, this is our responsibility. We as a group of individuals in our civilization are thinking about problems that are global in nature. And as a planet, we're thinking about problems that don't necessarily occur today, but will translate over time into the distant future. We also have insights about what's happened in the past. And I'd like to try and think about the world we live in for a moment in terms of first principles. So if we look at the planet Earth in terms of its boundaries, in terms of its area, about 30% of the Earth's surface falls within the boundaries of nations. And our civilization is written by the interaction of nations within that 30%. So in contrast, 70% of the Earth falls beyond the boundaries of nations in areas which are collectively identified as international spaces. And I would suggest for discussion that the basic responsibility we have as a civilization today and into the distant future, as long as there are nations, is to balance national interests and common interests. In the context of science diplomacy, we've talked about it in this meeting in a general sense. I'd like to provide as a straw man, a definition. That science diplomacy is an international, an interdisciplinary, and inclusive process. It's not a static point, it's a process to balance national interests and common interests for the benefit of all on Earth. I didn't say all humankind because we as stewards have responsibilities to think about the life and habitats of everything else on Earth. If we look at the history of our civilization, it was the 20th century when we truly became a global community. The first half of the 20th century was marked by animosity among nations, the concept of world wars. These were not regional wars, they were not wars that were in Asia or Africa or Europe or South America, they were world wars. And the concept of global expressed in terms of world. The second half of the 20th century can be marked with a sense of optimism and hope, in the sense that nations began to develop relations largely relating to environments in terms of treaties and conventions. And what you see in the blue area is the growth of treaties and conventions dealing with environmental issues. And during that second half of the 20th century, humankind defined explicitly regions beyond national jurisdiction. The first one was the high seas, the second one was the Antarctic, the third one was outer space, and the fourth one was the deep sea. So in a sense, if we look at the 20th century, the first half of the 20th century is expressed in terms of national interests, and with hope and optimism, the second part of the 20th century can be seen in terms of common interests. I'd like to try and think about science diplomacy for a moment with you in terms of what it is and what it can be. There are elements of this science policy interface that have been emerging for years, and it's been discussed broadly in many different forums in terms of that interface. I think those lessons can be consolidated and focused in terms of the contributions of science to humankind, to the world we live in. Science is certainly an instrument for Earth system monitoring and assessment, even a central gauge of changes over time and space. I'm not going to go over all of these in detail, but this one is particularly important because scientists think about the concept of time. More than any other group in our world, their focus is time, rate-dependent processes. And so, in a sense, we have a responsibility to help think about those challenges across different timescales, which are embedded. Science is an early warning system. Certainly things like the ozone hole that we alerted the international community and responded quickly to. Science is a determinant of public policy agendas, things like ecosystem change or smog or black carbon or whatever it is. Policy agendas come out of scientific insight, and it's an element of international institutions. Science is a source of invention and commercial enterprise. Seismic surveys that lead to insights about where oil and gases come from science. Science is an element of continuity in our global society, built on an evolving foundation of prior knowledge. And this is particularly important as we struggle with thinking about things that are of global scope, that the problems we face today cannot be solved within a political cycle. They relate to problems and solutions over decades and centuries. And in that sense, a good example is the international polar years. After the Little Ice Age in Europe, the nations of Europe identified that the crops, the economies of Europe were being impacted by weather. We would call it climate today, but they were being impacted by weather, and they convened the first international polar year. The second international polar year in 1932, 50 years later, related to the concepts of radio science largely. The third international polar year, which became the International Geophysical Year in 1957-58, looked at the Earth as a system with the notion of satellites during the International Geophysical Year. The fourth International Polar Year just happened in 2007 to 2009. So many of the issues that we're dealing with in terms of climate, for example, have a historical precedent that goes back more than a century in terms of nations struggling with the impact of weather/climate. Science is one of the subsidiary means for the determination of rules of laws provided by the International Court of Justice. This is a component of those rules of law in the sense of this is the boundary definitions of zones in the ocean, progressing from a coastal boundary through a territorial sea and contiguous zone in the water column through an exclusive economic zone out to the high seas in the water column. On the sea floor below that, there's continental shelf, and below that, the deep sea. And these are explicit zones. If we look at something like the law of the sea, in effect, we've got a gradient going from national interests to common interests. If we look at it in detail, 51 of the 320 articles in the Law of the Sea Convention, which is arguably the most elaborate convention dealing with any region issue on the planet, 51 of the 320 articles deal with scientific explicitly. There's a section explicitly on marine scientific research. So, and the last is science as a tool of diplomacy, fostering open dialogues to protect our common welfare and the world we live in. Probably the most prominent example is what happened after World War II, when we recognized undeniably that the world was going to construct intercontinental ballistic missiles. We had nuclear weapons unambiguously, and the challenge was at that time for Russia and the United States to begin thinking about their shared response to the development of ICBMs. This is going through the history of the National Security Council, various minutes and meetings and responses. We see that the concept of Antarctica, space policy, scientific, defense policy, nuclear weapons were all emerging during that period, and it was consistently brought into the same meeting that these discussions about science and policy and space and Antarctica were brought. And it was during that period that the Antarctic Treaty emerged. Now, the Antarctic Treaty brought together the United States and the Soviet Union to set aside nearly 10% of the planet for peaceful purposes only. In a sense, it brought adversaries and allies alike. And if you read this, that the establishment of a firm foundation for the continuation and development of such cooperation on the basis of freedom of scientific investigation in Antarctica, as applied during the International Geophysical Year, accords with the interests of science and the progress of all mankind. It was that scientific enterprise that brought nations, adversaries and allies alike, to establish a region of peace on the planet. And so, as such, science serves as a tool of diplomacy. Now, just in terms of opening the session, the Arctic is an emerging area of dialogue in terms of the geopolitics. And questions of stability in the Arctic are important just as they were in the Antarctic or anywhere else on Earth. There are two perspectives that come out of the Laws of the Sea Convention. The one is the perspective of the sea floor, in a sense, perspective of national interests. In contrast, the overlying water column, particularly the high seas in the center of the Arctic Ocean, is an area that's unambiguously beyond national jurisdictions. So in a sense, the Arctic is a test case about how nations will respond to the challenge of balancing national interests and common interests. And ultimately, in terms of all of this science and diplomacy, science and policy, I would argue that the most basic responsibility is to consider how we as a civilization foster stability and peace, how we promote cooperation and prevent conflict. So in that sense, I'd like to welcome Tim Dye to the floor to share insights about science diplomacy. Tim.